Okay, good morning. Welcome to this next OpenCloudification webinar. Today is May the 2nd, and we are back in Antwerp at the facilities of one of the partners of OpenCloudification, the Beacon, for a day of OpenCloudification interactions and discussions. And a couple of basic introductions before we head also to the agenda of this morning. So in the next 1.5 to 2 hours, we'll be talking about 3 different topics. And for that, we have a couple of guest speakers that we've invited, but maybe a couple of basic things first. So OpenCloudification is an activity that was started just 1.5 years ago in the attempt to really support companies in Belgium, Flanders in the first place, but also beyond, on understanding what open source technologies, open cloud types of technologies could actually mean for companies and for people that are willing to innovate and are working towards getting in the cloud, and then specifically, of course, using these types of technologies versus the known private and or public cloud facilities provided by Azure, Google's, or the AWS's of this world. So what we've been doing over the last 1.5 years, more or less, is to give insights on different mechanisms, different technologies, providing some backgrounds and also some practical advice on how to do those. And that goes both on the server side, so both the cloud management part as on the edge. Next to ourselves from LSEC and to the Beacon, we also have another very strong partner in this consortium, namely ID Lab, University of Ghent. And as the first speaker of this morning, you can already see that Thomas is present and ready to start his talk, which will be very interestingly about Obelisk, and a very interesting platform that helps in any case in developments that you might be considering, both for applications as well as in service deployment when it comes to identity and access. So without further ado, I'll hand it over to Thomas to help us understand what the potential opportunities and also capabilities are with the platform Obelisk as they see that. Thomas, good morning.
Thank you. Good morning.
You're not too far away from me, actually across the table, but still, thanks for joining in. And normally you should be able to share your screen as well. And so I'll hand it over to you. And good luck with the presentation. We'll see each other in a second.
So good morning, everybody. My name is Thomas. I'm a software engineer at ID Lab, working at IMEC and in Ghent University. I'm part of a small team that focuses on researching, designing, and developing cloud services and solutions, mostly driven by industry demands. Today, I'm going to tell you a little bit about Obelisk, which is our high-performance platform for ingesting data at large scale and having it queryable as soon as possible. So what is Obelisk? Obelisk is a cloud-native solution that acts as a queryable data sink for high volumes of time-based data. When we say time-based data, that of course includes the more traditional time series, but also event data that originates over time. Obelisk has support for not only primitive data types like numbers, but also number arrays, strings, and structured data like JSON strings. As long as the data has a timestamp, it can be ingested. Obelisk was first developed for the City of Things project that started in 2016. The project wanted to investigate how hardware and software could be combined to create smart city solutions. And for that, a high-performant IoT platform was required that could ingest all different sensors placed throughout the city of Antwerp. The many projects that would follow also needed query and streaming access to that sensor data to build new and innovative applications on top of that. So our answer to that was the very first version of Obelisk. We knew from the start that the requirements would only go up, so scalability was a major factor from the start of the design process. And since then, we've been improving, refining, and sometimes even completely rewriting Obelisk to better suit the constantly more demanding requirements that are expected of the platform. So maybe let's take a look at some of the typical use cases in which we think Obelisk might be useful. A first use case would be as a general purpose time series database. It can be a perfect alternative to InfluxDB, Timescale, OpenTSDB, or CardioSDB. And depending on your specific use case, we might be a better fit. A second use case is the original use case. It's as a smart city, IoT, or Industry 4.0 platform. Obelisk is used to capture sensor data and to build applications that consume this data. Some unique features that might facilitate this purpose are the multi-tenancy that we have. We can organize and isolate data in the context of different projects or teams, consortiums. We have fine-grained access control, which allows us to restrict access to data based on time ranges or labels set by the developers. And we have a geospatial component also, which allows us to query data produced in a certain region or location or area that you define. And a third use case would be to use Obelisk as a pure data sink for event streams. As I said, we support more than just numerical values, so that widens the range of possible applications. And a typical, more popular example lately is using it as a data lake that stores lots of data, arbitrary data, and that after capturing it will then be used to run some machine learning algorithms on. Then we have some applications in practice of Obelisk that I want to talk about. So some of the projects, first of all, City of Things, like I said, it was described as a test bed for smart city IoT collaborative research in a realistic citywide setting. And this Obelisk was originally developed, and it served as the main technical driver functioning for as a reliable data backend for most of the demos and prototypes. Later, we had the Smart Maintenance Project. This was a research project in the context of an Industry 4.0 setting and predictive maintenance in collaboration with Flanders Make. Obelisk was used here as a platform for capturing high volumes of sensor data produced during lab experiments with actual hardware test benches that would run tests on large mechanical components like large ball bearings and trying to wear them down. Another project was mBrain. This is context-aware health monitoring. It looks at application of machine learning algorithms to assess activities, sleep, and emotional state of users based on physiological collected data through wearables. Obelisk was deployed to handle the large volumes of data produced by the wearables that are constantly capturing data, and to also deal with the irregular connectivity intervals, because these wearables were connected to the users' phones. So for instance, when they went to sleep and some people turn off the phone, the next morning when they wake up, all the accumulated data would just burst through our platform, not always in a controlled manner. So it resulted in a lot of bursty traffic and unpredictable loads on the infrastructure. These first three projects, I've highlighted them in bold because they were actually defining projects for Obelisk. The first one, of course, because it laid the foundation of our platform. But then both Smart Maintenance and after that mBrain kept on pushing beyond what was possible at the time. So it required us to improve, adapt, and re-engineer parts of the platform to be more scalable and accept even larger bursts and higher throughputs. Some other notable projects are Port Forward. This project was set up to research a sustainable ecosystem for the European port of the future. Obelisk was used to build a multi-tenant interoperability layer for sharing data in a smart harbor context between logistics, freighting, and stuff like that. And then we have the ID Lab test beds, which are also known as iLab 2. We have the Home Lab and the Office Lab. Both are environments that are fitted with many different sensors that constantly capture data and send it to Obelisk. The Home Lab can be rented by a company to perform experiments with their own sensors. And the data is captured And the idea is that Obelisk is then a source where they can use the data and query their data to perform more experiments or analytics on. Office Lab is something similar. It's just it's our office in Ghent, where a lot of the sensors are fitted. So I'm gonna go over the architecture a bit, a very high level visualization of it to give you an insight in how everything works. Obelisk is built with many different services that are all exposed through one common API gateway, which you can see up top. The arrows here represent the flow of data, and the color coding might be interesting. So blue means data is going in, the green means data is going out, the orange is data discovery or inventory, and yellow is everything to do with authentication and authorization. So I think the easiest way to follow through this is just follow the data going in and out. So when we are ingesting data, the HTTP API is used and data comes in through the API gateway, after which it reaches the ingest service. A few things happen now. First of all, an authorization check. So this will use the access control service to check if the sending party is authorized to ingest data to the given data set. If this checks out, an array of data events is received. Each event will be partially validated. I say partially because we don't do schema validation or anything. It's mostly looking at is the timestamp correctly formatted and stuff like that. And then the event is posted on the message queue, and this is done in parallel. The message queue then has two paths where consumers are listening to. The first one would be the sync service. So this service batches up to 100,000 events or smaller if 2 seconds have passed. The 100,000 event batching is to make sure that we have a very large throughput for store operations. And the 2-second interval is to make sure that we don't have too much latency. But these properties are configurable. We can then horizontally scale the sync service to increase the throughput. The sync service is storing the data in the data store. And then we have another part that you can see that's going to the streaming service, which is an outgoing service. So interested parties can subscribe using an HTTP request via the API gateway to a data stream of a data set. And as you can see, this is a near real-time flow of data going straight to the consumer, even bypassing our storage. So this leaves us with the query service, which is another way to access data through regular queries. Again, via the HTTP API gateway, a request will be handled and the metadata store and data store will be used to fulfill this request. We have an inventory service that will have all the extra information for discovery about data sets, namespaces, metrics, and everything, which is again exposed through the gateway. And then we have the access control service, which will perform its checks by reading in a set of ACL rules. And as a last service here, we have the identity service, which does everything with authentication in the platform. So interesting now might be to look at the technology mapping on this screen. I'm going to go back and forth a little bit because there's one notable change immediately. And that is that the metadata store, the ACL rules, and the identity store are all three fulfilled by PostgreSQL. This allows us to keep the dependencies to a minimum at runtime. Other technologies are traffic for the API gateway. We use Kafka as a message queue implementation. Our data store is ClickHouse, which is an online analytics processing column store. ClickHouse is a general purpose OLAP store, but there's been a lot of careful consideration has been put into designing a schema for Obelisk with various optimizations for dealing with time series. I'm thinking of index selection and compression codecs and everything to make it perform as we want it to. The access control service is fulfilled by OpenFGA. This is a relationship-based access control system. It's an implementation of the Zanzibar paper by Google. For those who don't know it, Zanzibar handles authorization for YouTube, Google Drive, Google Cloud, and all of other Google's products. The identity server that we use is Keycloak. It's an open source identity access management solution and was originally developed by employees at Red Hat. It's open source now completely and it's well maintained. It follows the latest security recommendation and specifications. In short, it allows us to leave security to the experts. Another interesting thing might be in the lower corner left. All the Obelisk services that we write are developed with Quarkus and are all JVM based. So Obelisk is built with a cloud native first approach. So what we mean with this is all the existing technologies that Obelisk uses are all on the CNCF landscape. Both in deployment and operations, we try to leverage the best practices in cloud. We are using the full range of Kubernetes constructs as much as possible. We ingress with traffic to divert incoming requests to the proper services without them needing to be aware of it. Secrets config mobs to store sensitive and common configuration data. We use readiness and liveness probes to check the health and life cycle of all the running services. And of course, in the development itself of Obelisk, these concepts are constantly in the back of our head. For instance, we're a very small team, so it's much more pragmatical to have a mono repository. But our CI/CD pipeline is set up in such a way that we can deploy everything to individual microservices, while we're still able to run it as a monolith in development and testing, for instance. We also employ the fail-fast approach, so we're counting on Kubernetes to bring a new instance of a service up as soon as possible in the case of failures. And all these things combined, for instance, make sure that we have an independent boot order, although we have many running services. Another thing that is key for us is developer friendliness, because we want, of course, people to use Obelisk. So that's why our whole API is just basic HTTP based. It's completely documented in OpenAPI 3.0 specification. And Obelisk also comes with a complete inventory and management API built in, which is not something you always find in time series database storage competitors. Data can be sent with a regular HTTP posts. It can be queried with a regular HTTP GET and some query parameters. You get normal responses with or a streaming response based on the accept header. Inventory and management APIs are simple: create, remove, update, delete on the resources. And we see extensive documentation as a requirement for success. So it's something that we actively keep on improving on as much as possible. The current public version is already extensively documented. The version that I'm presenting now, a bit more on that later, it's ongoing still, but it's something that's high on our priority list to have more and more documentation, not just an OpenAPI specification. So then a little bit about security and authorization. As I mentioned, we're using Keycloak as an identity solution. The very first version of Obelisk already used Keycloak. It was chosen because it has excellent support for OAuth 2.0 and OpenID Connect 1.0. Throughout the version bumping and rewriting of Obelisk, we've dropped Keycloak once due to the authorization options that were not a perfect match. But we then implemented our own authentication-based authorization and authentication based on the same specifications. And now with the new version coming up, we are reintroducing Keycloak because of a few key benefits that it has and a few circumstances. First of all, Keycloak is well maintained by the developers. That has been proven by now. It follows security vulnerabilities and patches known attack vectors very quickly. So it's something we don't have to look out for as long as we keep up with Keycloak versions. It already follows the new OAuth 2.1 specification, which is still in draft and is sort of a consolidation of OAuth 2.0 and every extension that's been added to it. Keycloak also acts as an identity broker for various other identity providers, which is a very big plus for us because that means we don't need to store credentials, and that's something we don't like doing since it's not our core business and then they can be stolen. Some limitations that we had with Keycloak access control in that first version, those were based on Keycloak's authorization rules being resource-based, and that did not really fit with our contextual API endpoints that we had back then. Now we have inter-dataset relations that inherit rights of a parent dataset that would not be easy to model, and namespaces can have access control, so that would imply transitive rights on children, which is again hard to model. But now we are using OpenFGA for access control, so this problem is not a non-issue anymore. Keycloak is now a pure authentication way for us, and the authorization is then handled by OpenFGA. Like I said, OpenFGA is a relationship-based access control system, and it allows us to enforce all these difficult access control patterns up until the level of a data set. But with Obelisk, we allow access control to go even further than that. But it's no longer handled by OpenFGA then. It will be in the last steps. They are data attribute level enforcements that are handled by the services themselves in the form of filters. To have an example here, some data attributes that we can use are, for instance, the time-based data set I was talking about, the home wrap earlier. For instance, when a company goes there for 2 or 3 months and tests something new that is still on a non-disclosure agreement or something, we can access control the data on our sensors that keep on sensing and capturing in a specific time range. We can also do the same thing geographically and even with labels. And when data is ingested, labels can be added freely, so there's a lot of flexibility there. Then there's the question of deploying an operation. We have deploying and operating Obelisk on Kubernetes since the very beginning, since Kubernetes version 1.6. We then quickly moved on from deploying plain Kubernetes manifests to the more manageable Helm charts. So Helm is the sort of the package manager for Kubernetes. We have an Obelisk Helm chart, which includes all the core services of Obelisk, but not the external dependencies. Those are still installed separately. Most of the time, also using a Helm chart, just ClickHouse is using an operator. And many of these dependencies can also be swapped out for equivalent other cloud services. For instance, Kafka could be filled in with Azure Event Hubs, or we could use a hosted ClickHouse somewhere. And this chart is maintained alongside and tested alongside the code base, so it's versioned together with the code. Currently, we use Helmsman to manage the installation and upgrades of the entire Obelisk software stack, so that means core services and dependencies. Helmsman uses a desired state file that describes the different applications, their configuration, their chart versions. It simply allows us to install all the charts in one go or roll back the entire stack in case of failure. And in the future, when we have some time, we would like to streamline the deployments by developing an operator or a wrapper Helm chart to install everything at once. So then I have something about the data standards, because that's a question that comes up a lot. So in the past, efforts have been made to support various data standards, including DCAT AP for exposing our metadata catalog information. We also provided additional interfaces that comply with the FireWare NGSI and NGSI-LD data interoperability specifications. And although it's relatively easy to provide some working prototypes, implementing and maintaining a high level of spec compliancy is difficult with a smaller team, especially for something like NGSI LD, for example, because it has a design by committee nature. And that was often a mismatch with Obelisk, which was a pragmatically evolving platform, which is continuously evaluated and improved based on real use cases and applications and industry demands. Our current strategy for standards is to support them via first-party or third-party extensions instead of implementing every possible integration as part of the core platform. Some possible interesting candidates that we see now for future support is IDSA, the international data spaces. There, Obelisk might participate on the data plane level. And on the other hand, we have Solid, which is a web decentralization initiative led by Sir Tim Berners-Lee. We could expose Obelisk time series data in a Solid compatible way. Yeah. As ID Lab, we're also involved in the Solid Lab Thomas project, so that's a way of looking where we can add that. So I've been continuously saying that we've redesigned Obelisk a few times already. So I think it might be interesting to go over a small high-level evolution of the versions and the biggest differences. So it started in 2016 with City of Things as an IoT platform that we made. The focus there was the IoT use case. The main data storage solution that we used back then was a single InfluxDB instance, and the message bus was provided by Kafka. So with projects like smart maintenance, the Industry 4.0 case that I mentioned earlier, the scalability was quickly put to the test, and we did a full redesign to version 2. The focus was stability when scaling up and the ease of use by employing all the lessons learned from the first version. Storage was still provided by InfluxDB, but we were using multiple shards. However, the pricing on sharded InfluxDB solution was very steep, so we rolled our own custom sharding solution on top of many single InfluxDB instances. Message bus was still the same. Then we quickly, and the team has always been small to do all this, developing, operating, maintaining. And back then we also did the onboarding of many new projects, but it was too much work. So that led us to make a third version, which was of course able to scale better because there were more and more demanding requirements. We did this in part by introducing a new data storage solution, which was ClickHouse. And we also had self-service management, which allowed onboarding by the users themselves. The message bus also evolved to Pulsar. At the time, it seemed a good contender for Kafka with a more modern and developer-friendly API and better documentation. And also, still being in a research role, it's important to evaluate new technology, so it was a perfect opportunity to try this out. But projects like mBrain, like I said, with the bursty nature, the variables that connected when the connection was coming back up, it was again pushing against the burst potential that we have for ingest. So an experimental side version was developed that would allow high frequency storage, which is an edge case, but the problem was that those few projects with that edge case were putting a lot of stress on the current platform. So it's a bit of a special version because it was deployed next to our version 3. And we moved over all those projects that were an excellent use case for this with high throughput, or typical projects that would have a machine learning use case where they were used as a sort of data lake, and then machine learning was done on it by querying it constantly. It was still using ClickHouse, and we moved back to Kafka. This was because Kafka was more mature by then. The developed documentation was already better, and we also saw many industrial partners having a managed Kafka instance in their cluster of cloud offerings, so it would be a better match for us. And then we're coming to the final version. This is the one I'm presenting now. It's what we've been working on for the past months. It's not live yet, but it will be it's very close to launching. And one of the main motivations here, apart from, again, the obvious increase in performance and scalability that you always want to have, was having a good base to open source and having a strategy for maintainability. So we focused on a lean and mean Obelisk core with the bare minimum of required features. All other features will be moved to Obelisk services layer. The storage is still handled by ClickHouse because we're very happy with its performance. And the message bus is still Kafka for the reason I said in the previous version. It's just a better fit for industrial partners. So we still have some future plans for next iterations or nice to have features. The things we're thinking about is a small scale deployment or federation setup. It could act as an edge computing case where a small-scale Obelisk instance is deployed close to the data sources, and then they pre-aggregate data before sending it to a main Obelisk cluster. This can be interesting in many cases, for instance, limited resources on the edge, limited bandwidth in the uplink, or an expensive data transfer cost on the uplinks. It could be beneficial to have those small-scale deployments not needing a cluster to run, and being able to run databaseless on the file system, for instance. So these are avenues we're exploring. Then other things we're looking at is more data extraction options. In all the versions, a lot of effort has been put into the scalability of the ingest to be able to capture as much and as quickly as possible. But we think there's still more work that can be done on the query side, functionally then I mean. IDs here are Jupyter Notebook integrations, interactive dashboards, or basically integrations with any other existing popular technologies. And then something else which has become more important is a simplified deployment process. Obelisk can be run on premises by other people or companies, but installing Obelisk still involves a very extensive guide with lots of manual setup and verification. And the goal would be to have some kind of concise descriptive configuration file and just an installation one-liner. Within this topic, we're also exploring the development of an operator, like I said, to fully manage the setup, the core services, and the external dependencies. And there's also a research track running into the development of a generic operator for data-driven applications. I'm just gonna give one more bit of information about this division between Obelisk core and services. So the Obelisk core concept was very important for us for a few reasons. Like I said a few times, we have a small team working on this. So keeping it to the bare necessities will allow us to have faster development cycles. We can move forward without dragging all the dependent services along that have to be updated every time we add a new feature to the platform. We can keep it maintainable for our own team, and it prevents feature creep in the core platform by offloading all project requested extras to the Obelisk services layer. The Obelisk core will always have all required components to function properly on its own, and it will always be open source. That's why it's an official pseudo-layer license. The Obelisk services then are a shell around the core. They can add more interfaces using the core. They can come in the form of data generators or processing plugins or view plugins. But the licensing of these services is the choice of the developer. We will ourselves release some functionality as an Obelisk service that might very well be open source, but a third party might develop a service and license it however they see fit. And with this separation and the Obelisk core going full open source, we hope to build a community that provides important feedback and can report on issues that they might find. It will also allow companies that want to use Obelisk to always have the option to fork and adapt it to their own needs if we can't fulfill their demands. So that was all I have. I want to thank you for listening. The first thing you can see is our code base. Right now, it's the code base of the public version 3. That's public right now, but it will change to the newer version once we launch. And the second link is a landing page with some information about the next version. You can also find a materials link down below with a link to these slides if you're interested. So if there's any questions, you can ask us, the whole team is here.
I have two questions. Maybe they're already answered with your last slide as Obelisk services. First off, was wondering, is there any way to manipulate the data as it's coming through this, or would you typically build an Obelisk service that would be meant for you and then persistent in the database?
So if you, I see you nodding, if you want to answer it also.
As of now, there are two options. There's a streaming API, so we could listen to data as it's being processed by our system, then process the data client side, and then insert the resulting data via our ingest API. For trusted processing, we also do consumers and processing on our cluster, which then connects directly to the platform. There you could also do stream processing. That's something that we would like to have more infrastructure. Like there's that could be a managed system that accepts like double containers that do the processing to make it easier for people to processing on a cluster. That's still in the works.
Secondly, it's a bit related. Are you looking at other options for ingesting the data itself, like maybe through an IoT broker?
In the past, there was an additional component developed by ID Lab. It's called Diamond that did a lot of the interfacing towards lower level devices for us, and that included like broker. But that's a project that is now spin off, so we don't have access to that code base anymore. But I could see that an alternative evolving to Obelisk extension.
Maybe another question would be if a company is interested in knowing more and trying to maybe start using Obelisk, what's the best way for them to do it?
Pragmatically, I would say send us an email and we'll make sure we get into contact with them.
But what would be the most suitable use case for you to get started from anybody out there?
Just to try it out, you need to test it.
Well,
I think if you just clone the code base, like I said, we actually have a monolith option to just run it, and you can already interact with it, play with it. Of course, it will not have the same performance than when you run it on a cluster, but just to get a feel for the possibilities, there's not really any function missing when you're running it as a monolith. So that would be the easiest way, I guess.
I think that's maybe something we can link to the website if someone is interested in the Open Cloud website, so they have direct access. Is it something that can run on the Linux environment?
Yeah.
The monolith that we are using actually runs on Docker, so it should be runnable on any laptop. Performance will depend, of course, but
I have a question about the storage itself. Are there options for compressed storage or encrypted storage of the data?
Compressed is built into the current schema. ClickHouse also allows encryption at rest. It's a configuration option. Other than that, it's not really any specific.
And do you have any numbers of like what the average compression value is of the data that you see?
it's quite impressive. I think that
It would be like compression ratio.
yeah, it greatly depends on the types
Yeah.
of data you're sending, of course. You can compress numerical values much easier, than large structured data, but
I think at least a factor 3 and up towards factor 15 from memory.
ClickHouse has a lot of compression options, and it's something we've been tweaking a lot. It's not just okay, it's a numerical value, let's use this compression type. If you know it's something that fluctuates a bit like this, you can compress it completely different than something that has a lot of increases over time. And so depending on which column you're compressing, we can another compression algorithm.
And then the way how you order data is great. If you put data that's coming from a single source close together, that's one of the things that we try to focus on. the way how we set up API.
And maybe to answer part of your question, Billy, in terms of use cases, my view is that if you are a company that has a lot of streaming data and you want to build applications that process, use, create value with that streaming data, they have to be responsive and they have to be able to process large amounts of data. This is the type of platform that solves a lot of the data ingest, data storing, data processing problems for you. You see, for example, Obelisk uses ClickHouse itself too, but it's like in any company that uses ClickHouse, there's so many stuff that you have to build around it. Normally, that you have to build yourself. With Obelisk, this is all provided for you, and you can really focus on just creating services that call these APIs to actually use and process the data, instead of having to think a lot about how to store it, how to ingest it, and things like that.
Yeah. With if you would compare it with something that exists in the commercial markets, what would you compare it with mostly? So to see how people can relate to it.
Sure. I think any IoT offering of a big cloud vendor, something like that. So.
It's difficult to compare
Yeah.
because most times those are building blocks. Well, we go more towards like
A platform.
yeah.
And another difficulty in comparing it is that most of the time you have to choose between either we're storing objects or we're storing streaming data. While with this, as long as your data has a timestamp, it can save your data. It doesn't matter if it's just like JSON objects with timestamp, it can still store your data. And it's pretty unique in that sense. Like the Azure IoT offering, for example, it has a lot of features to store IoT data, but then from the moment you really want to query JSON objects, there's where it falls short.
Yeah.
It's also a bit of a paradigm shift that when you say time-based, everybody thinks of a normal time series, numerical values with a timestamp, but actual events are also timestamped most of the time. So, and it's not just an afterthought, because you can do very powerful things with that too, when storing them. So.
I see the same challenge as you were describing on Azure, like with the Siemens platform. It's the same philosophy. So. Okay.
Thank you very much.
Thank you for
Very interesting.
showing the something. So, okay, I guess Marlene, we can switch over to you. And on the original agenda for today, we.
Yeah, I see that my microphone is off, so this might be a little bit easier now. So as an additional topic for today, we originally had planned for a topic on FinOps. Now that is still planned, but it's unfortunately not going to happen today. The FinOps topic will be probably presented at a later point in time. But on today's session, Marlene will be able to talk about